In this section of chapter 14, I will discuss about carbohydrates with 3 and 4 chirality centers. So basically we'll be discussing Fischer projections. Again, just to refresh your memory on this, we discussed this in section 1. For Fischer projection, you will have to hold the molecule like this so that CHO is on the top and CH2OH is on the bottom. When you arrange it that way, hold it that way, then you can look at chiral carbon next to CH2OH group, and if it is on the right side, it's a D, and if it is on the left side, it will be an L. And don't forget that each carbon has hydrogen also. So I'm just showing you one of them. So we discussed about it. We can also present the same Fischer projection in this manner, where hydrogen and OH are projected toward U. Now, the projections we mentioned about in first and last section are very much similar, except that at that time we discussed about 1 and 2 chirality centers in the molecule. Now we talk about 3 and 4 chirality centers. In this slide, we are looking at carbohydrates with 3 chirality centers. Let me identify those. This is one of them, second one, third one. These are all carbon. Now, so with these 3 chirality centers, we'd expect 2 to the power 3 isomers. That means there should be 8 isomers. And out of 8, 4 of them would be D and other 4 would be L. Now D and L, in case you forgot, let me remind you that with another color of the pen. Look at the chirality center next to CH2OH group. This is the one. Focus on that carbon and the OH. If OH is on the right, then is D. If it's on the left, is L. So basically, you first get the D and then take the mirror image. That would become L of that particular compound. So the first compound you're looking at is D-ribose. Then we have D-arabinose, D-xylose, and D-lysose. So I remember it this way, RAXL, REXL, as if it's like T-Rex. So REXL, you can consider it to be genetically altered from T-Rex. So remember REXL, R for ribose, A for arabinose, X for xylose, L for lysose. Now we're going to show you that you don't really need to memorize these configurations. You can predict the configuration. And that's what I'm going to show you in next slide. Here I'm going to show you how we can predict Fischer projections for ribose, arabinose, xylose, and lysose. So let me first write down R, A, X, L, ribose, arabinose, xylose, lysose. Now, keep in mind there should be 3 chirality centers. So, and you must have CHO on the top and CH2OH on the bottom. This is how you need to hold on to it. So let's first write down just these 2. So CHO on the top. So each of these sugars would have CHO on the top and CH2OH on the bottom. And I'm going to write down all the D configurations. So first I'm going to write down D ribose. I may not have space to write down or spell each such sugar, but since it's D ribose, OH group in the bottom chirality center would be on the right. So that's OH. Since next one is D, arabinose, is also going to be on the right. D, xylose, OH on the right. D, lactose on the right. So I'm coming up with the right configurations. Keep in mind, I have already assigned one chirality center and there are two other chirality centers for this compound. Now I'm going to start the top chirality center next to CHO. So keep this in mind. First write down CHO on the top and CH2OH on the bottom. And then since for D, all the OHs will be on the right side. This is at the chirality center next to CH2OH group. Now you start from the top chirality center. That would be the second one we're taking care of. You just apply right-left rule. That means first one will be right, next one will be left. Then next one will be right, next one will be left. Now the next chirality center would have first two right, next two left. So this is right, this is right, left, this one also left. Now you got the configuration of all these sugars, ribose, arabinose, xylose, and lactose with three chirality centers. So keep that in mind. This is D arabinose, and this one is D xylose. Make sure you know these names, and D lactose. So what I'm trying to show you is, without memorizing Fischer projections, you can predict it. Now we are going to show you carbohydrates with four chirality centers. So let me identify those four in one of these molecules. This is bottom one, 2, 3, 4. These are all carbon. Now since we are going over D, so my bottom carbon, bottom chirality center would have OH on the right, OH on the right, OH on the right, OH. So I'm just filling in with OHs, OH, OH, OH. Okay, so I took care of D. Now I need to go to the top chirality center. The top chirality center I'm going to identify with blue, so that you know. Now I need to start from there. Again, I'm going to use right-left rule. The first one would be right. Next one, OH would be on the left. Next one on the right. Next one on the left. Then right, left, right, left. So I'm done with the top chirality center and orientation of OH group. Let's move to the next one from the top. This time it would be 2 right and 2 left. So first 2 would be on the right, next 2 would be on the left, next 2 would be on the right, and on the left. Okay, so let me remind you again. The topmost chirality center would have right, left, right, left, right, left. That's how it goes. And then next to it, you would have 2 right and 2 left. And then come to the next chirality center, you'd have 4 right and 4 left. So let me use a different color of the pen. 1, 2, 3, 4. I have assigned all 4 to the right, and next 4 would be all to the left. OH, 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 and OH. Now I'm done with all these Fischer projections for series of carbohydrates with 4 chirality centers. The first one is called allose, D-allose. Next one is altrose, glucose, mannose, glucose, idose, galactose, and talose. And keep in mind, we have 4 chirality centers, so total isomers to be 2 to the power 4, 16. 16 isomers, and out of 16 isomers, 8 would be D and other 8 would be L. So, and we wrote down all the D's. Remember, D isomers having OH to the lowest chirality center, which is closest to CH2OH, is on the right. That's why it's D. Their mirror image is going to be L. So keep that in mind. Here I'm going to remind you how we come up with all those names without really putting too much effort in memorization. All altruists gladly make gum in gallon tank. My professor taught me this way, and I still remember that, so I think it was very helpful. All for allose, then altruist, ALT, altrose, then glucose, then mannose, then glucose, idose, galactose, and talose. So I wrote that part of sugar that I need to know in red. So you can say that all altruists gladly make gum in gallon tanks. Just follow those red letters. Now let's go over a problem from page 478, and this is problem number 8. Now there are several parts in this question, and let's do A. I'm going to show you how we can predict it without really memorizing structure. The question is, let me write down that, L arabinose. So I'm going to write down that. Now we know that we are going to get D arabinose by applying the rule I mentioned, and then I'll get the mirror image, and then that would give me, from D, the mirror image is going to be L. So let's see how we can find out. First, you need to know that arabinose is part of which particular sugar? Raxel, ribose, arabinose, xylose, lactose. So let's just write down those CHO and CH2OH. This is pretty much like your work before you find out arabinose. OH, then CHO, CH2OH, and then CHO, CH2OH. Okay, now I'm going to write down all these, so must have OH on the right. So let me write down, remember, Raxel, ribose, arabinose, xylose, lactose. So all right on the right, right. Then the top one would be right and left. This is right, this is left. I don't need to go farther because arabinose is the second one. Remember, there'll be 3 chirality centers, so I have one more left here. It'll be 2 right and 2 left. As soon as I get 2 right, I already reached arabinose. So this is arabinose, D-arabinose structure. So let's write down D-arabinose first, and then we're going to get the mirror image of that, and that would be the answer to the question that they're asking for. So let me write down that. CHO on the top, CH2OH on the bottom, and I'm just copying this from here to here. You'd have this OH on the left, next two OHs on the right. Okay. Now what I'm going to do is, I'm going to get the mirror image. Let's assume that I have a mirror here. Let's reflect it to get our answer. So I'm going to write down that in a different color. CHO and CH2OH on the bottom. Now remember, I have OH on the left. In mirror image is going to be on the right. So left becomes right, right becomes left. So let's do that. So you can see here, this OH will be reflected here, OH will be reflected here, so everything is all right. Now this is L arabinos. That's what they're asking in this question. So this is my answer. Now why I did all this work? Because I didn't want to memorize my configurations. Now we're going to do another problem. Now this time the problem would be 8C. So in this case we're going to do L, again this is also L, galactose. So L galactose. Again, in order to figure out this, I'll have to remember this. It's coming, galactose is one of those sugars like all, altruist, gladly, that's for glucose, make, gum, that's glucose, in gallon tank. And gallon, that's galactose. So in order to figure out this, again I'm doing some work because I'm showing you how do I remember it without memorizing these structures. First write down CHO on the top and CH2OH on the bottom. In each case, CHO on the top, CH2OH on the bottom, 3 CH2OH, there are quite a few, CHO, CH2OH, 1, 2, 3, 4, I have 4, then 1, okay, the next one would be again CHO, CH2OH, 1, 2, 3, 4, 5, 6, now I have 2 more, CHO, CH2OH, and then CHO, CH2OH. Okay, so this comes from, this 8 come from 2 to the power 4. Remember, you'd have same number of D's and L's, so these are all D's, 8 of them, other 8 would be L, mirror images, so altogether 16, 2 to the power 4. So that means this is coming from 2 to the power 4, there'll be 4 chirality centers. So that 4 chirality centers, let's just put red mark so that we don't make mistakes. 1, 2, 3, 4. Let's just do it on first one. Now since these are D's, all OHs will be on the right. On the right, 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 right. Now we'll be moving to the topmost chirality center, and we're going to apply right left rule. Right, left, right, My writing is not that clear in some cases, so I hope you can still follow. Right, left, then right, left. Make sure we double check when I'm doing things in a hurry. Right, left, right, left, right, left, right, left. Okay, then 2 right, 2 left, then 2 right, next to right, next to left. Then I would have 4 right and 4 left. This gives me all those carbohydrates. This is 3, 4. So this would give me all the carbohydrates with 4 chirality centers. 2. I'm now writing down the 4th, 3, and the 4th. It got a little messy because there are too many sugars I wrote down in short space. The first one is allose, maltose, glucose, mannose, glucose, idose, galactose, and talose. So this question is asking for galactose, so let's just take out this structure. And so what I have drawn is D-galactose. And from D-galactose, I'm going to get L-galactose just by taking mirror image. So let me show you that. Let's first write down D-galactose, and then we take the mirror image. This is CHO, and then CH2OH. I'm just copying what I have already got, OH, and then other 2 OHs on the left, and then the bottom OH is on the right. So that's galactose, D-galactose. So this is D-galactose, and I'm getting mirror image of that. Let's draw that in red so that you know that that's your answer. Again, right becomes left, left becomes right when you take the mirror image. So OH will be left now, from right it becomes left. Now those left OHs becomes right, OH, OH, and the first one will be OH here. Make sure to double check that you copied everything right. And so this is L-galactose. So this is the answer to the question. Keep in mind, I haven't memorized this structure. I predicted the structure based on all altruists gladly make gum in gallon tanks.